G'day nerds, today we're going to look at molecular geometry. Now by the end of this you should be able to explain for me the shapes of different molecules. And I remember a molecule is a free, independently moving particle and how that affects their polarity as well. So this is your vocab, just write this down and yeah, we'll be able to refer back to it as we go along. So we start with water. Water is a polar bent molecule. And we see it's got the angle here of 104.5 degrees, and the distance between the bonds, or the bond distance here, is 0.9584 angstroms. Now that's about 95 picometers, 95.84 picometers. So that's actually quite a small bond, and that's because oxygen is very electronegative. So it pulls the hydrogens close, and that's because it's trying to pull in the electrons. It pulls the hydrogens close due to the electronegativity, and this gives us a bent linear shape with these polar bonds, and the polar bonds have an asymmetrical function, which means we have a net dipole. This symbol here is how we talk about the dipole moment, which is the movement caused by a polar bond. And you can see that if we add these two together, it's got an overall dipole of this direction, so they add together. So yeah, and that's because the oxygen is more electronegative, the hydrogen is more electropositive, and we can see that it will push in that direction. So then we look at dihydrogen monosulfide. Now dihydrogen monosulfide is a very similar molecule, but what we'll notice is that it's 1.336 angstroms in this bond length, and the distance, sorry, the angle is not as wide, it's not as broad, it's a bit closer in. This is because the polar molecule is, yes, it's polar, and there is a large electronegative differential between sulfur and hydrogen, but it's not as big as oxygen. So because the differential is less, we actually see that these aren't pulled, like the hydrogens and the sulfurs aren't pulled as close together as the hydrogens and the oxygens were, which means because they're a bit further away, that angle is allowed to be a bit narrower. And this is a bent linear molecule. And it's also asymmetrical and polar, which gives us a dipole moment. In other words, it has polar bonds between atoms, but the overall molecule is also polar. Then we have carbon dioxide. Carbon dioxide is a linear molecule, okay? And that's largely because here it's sharing electrons, and we'll see that it's actually sharing two pairs of electrons. And because it's sharing two pairs of electrons, it gets that more straight shape because it's got to keep those electrons together on either side. It does have dipolar moments, which we see right here, and the oxygen being more electronegative than the carbon. And because it's got those dipolar moments, what is actually happening is they even out. It's symmetrical, which means this is a non-polar molecule with polar bonds between the atoms. Now let's look at ammonia. Now ammonia has 3 unpaired electrons on the nitrogen, and each hydrogen has 1 unpaired electron. So we end up with 3 bonding pairs here and 1 lone pair. Again, it's not a bent linear because there's an extra one in there, so it becomes this trigonal pyramid. And the distance is 101.7 angstroms. Now, 1.0717 angstroms. This means the hydrogens are further away than they are with the oxygen, so the angle can be, a bit narrower, but it's built amongst 3. But compared to sulfur, which is even further away, we can see that this one's wider. This one's wider because it has to be the nitrogen is more electronegative than the sulfur, so those hydrogens have to be just that little bit closer to the nitrogen, so they can't quite get as close and narrow. These all have dipole moments for each bond here, and it's asymmetrical, which means all of the dipoles are heading in this direction. They're not cancelling each other out, which means we have a net dipole moment or a net polarity. So this is a polar molecule, which means there is an uneven spread of charges, and it's heading up that way, above the nitrogen. So yeah, polar molecule with polar bonds in between. I hope that made sense. If it didn't, put any questions you have in the comments below and we'll get back to you as quick as we can. Thanks for watching. and hit subscribe so you can keep up with everything we're doing, and blah, blah, blah. And we'll see you next time. Thanks for watching. Bye now.